Hi there. It's important to understand the basic functions of each piece of equipment in the studio. But the thing that is really important is how all of the equipment works together to create different styles of mixes. That is, how all the equipment works together to create good mixes, rather, great mixes. We will then have a framework for the discussion of different values for different types of mixes. Then we can have some really good arguments. We'll actually have something to argue about. In this video, we will explain the basic functions of all of the equipment in the studio. Using visuals of sounds, we will explain the most common parameters found in each piece of equipment. This video is an introduction to the basic functions of equipment. The idea is to explain each piece of equipment visually, so that in the next video, we can use these visuals to show different types of mixes. We will go into more detail on each piece of equipment in future videos. In order to make the huge variety of studio equipment fathomable, let's categorize all of the equipment based on its function in the recording process. Sound creators create sound. These include acoustic to electric instruments, from vocals to synthesizer. Sound routers route sound from one place to another. Mixing boards route the signal to 4 places: the multitrack, the speakers, the headphones for the band out in the studio, and the effects so we can have a good time. Patch bays are just the back of everything in the studio next to each other. It's the back of the mix panels, the back of the multitrack ins and outs, back of the console ins and outs, and back of the effects ins and outs. It's the back of everything next to each other so we can use short cables to connect everything in the studio. Sound storers store sound. Tape players store digital or analog sound. Sequencers store MIDI information. Sound transducers are equipment that take one form of energy and change it into another form of energy. Microphones take mechanical energy or sound waves and change them into electrical energy. Speakers take electrical energy and change them into mechanical energy or sound waves. But it is sound manipulators that we are here for. This includes effects and processing that are used to change or add to a sound after it has been created. Now, there are only 3 components to sound: volume or amplitude, frequency, and time. That's all she wrote. Every single sound in the world can be described fully and completely by these 3 components. Therefore, every piece of equipment in the studio controls one or more of these 3 parameters. Here's a chart showing all the sound manipulators in the studio. Volume of the faders is shown as a function of front to back. Frequency is shown as a function of up and down. Time is shown in real time. That is, when a sound occurs, the visual representing that sound will appear and flash. In the first video of the series, we showed how we mapped out volume as a function of front to back. As previously mentioned, we can use volume faders to place a sound out front, in the background, or anywhere in between. In the next video, we will cover how volume relationships can be used to create different musical dynamics.
When we set volume relationships in a mix, we use apparent volumes to decide on the relative balance, not just the voltage of the signals going through the fader. If we were just using where the faders are set relative to each other, then we could mix without even listening. We could look at the faders and place them based on their relative placement, like this. When we raise the faders on the board, we are changing the voltage of the signal being sent to the amp, which boosts the wattage, which then sends more power to the speakers, which create more sound pressure level in the air that our ears hear. However, there's more to it than that. The other main thing that affects apparent volume is the waveform of the sound itself. For example, A chainsaw will sound louder than a flute when they're both exactly the same volume on the VU meters. A screaming electric guitar sounds louder than a clean guitar sound, even if they're both at exactly the same volume.
So when you see sounds represented by spheres between the speakers, you're seeing the apparent volume of a sound. This is what we use to mix with. This is what we use to set volume relationships. You don't look at the faders, you listen for the relative volumes.
Bass.